Welcome to a new class. This time we're discussing meteorology for air pollution control engineers. So let's start by talking about the atmosphere. The atmosphere is well defined down there. So the lower boundary of the atmosphere is really perfectly shaped because it is bound by the land, by the oceans, mountains. So the lower part of the atmosphere, we really know its boundaries very well. However, the upper boundary of the atmosphere is not very well defined. Why is that? Because as we go up in our atmosphere, it keeps getting thinner and thinner until it disappears. So it's really very hard to draw a line and say this is where it starts, this is where it finishes. So it finishes gradually on a very long distance. So 1/2 of the mass of the atmosphere is within 3.5 miles of the surface, and 99% is within 20 miles of the surface. So 3.4 miles is where most of the things happen. And in 20 miles, that's where 99% of the atmosphere is. The large width and small depth mean that the most of the motions in the atmosphere must be horizontal. Now, I want you just to look at the numbers. The numbers here mean that. You just get the pointer. The numbers of 3.4 miles, this is around 5 kilometers. 5 kilometers is a very, very short distance. Imagine how much you drive 5 kilometers. You just go to the nearest gas station, you probably drive more than 5 kilometers. But going up 5 kilometers, that is half of the atmosphere already. So that's the vertical. Now, horizontal, you have to infinity. You have the whole Earth. So that's why we're saying there is a very large width because it can go all around the Earth. And there is a small depth because it just doesn't go really up very well. And most of the motion must be horizontal. Except for very rigorous storms, the vertical motion in the atmosphere are 1 or 2 orders of magnitude smaller than horizontal ones. The vertical component of the wind velocity is 1 or 2 orders of magnitude less than horizontal component of the wind velocity. So most of the wind is going right, left, north, basically north, south, east, west, but it doesn't go up and down. Similarly, atmospheric storms and systems are thin. A tropical storm is typically 200 miles or more across and 10 miles from top to bottom. What does this mean? Horizontal atmospheric motion. That means that the motion horizontally is driven mostly by uneven heating of the Earth's surface and modified by the effect of the Earth's rotation and the influence of the ground and the sea. So we do have effects caused by equatorial heating and polar cooling. So on the equator, we have much hotter temperatures than on the poles. And this difference in temperatures make a very big impact on direction of the atmosphere. The Earth rotation also has an impact on the atmosphere because it goes in a specific direction. So on the above the equator, you will have one direction. In the south of the equator, you have another direction. And finally, the influence of the ground and sea plays a very important role in the atmospheric motion. The surface of the ground heats and cools rapidly from day to night and from summer to winter. That happens because solid ground is a poor conductor of heat. However, the surface of ocean and lakes heats and cools slowly, mostly because their surface layers are stirred by winds and by natural convection currents. So there is a lot of mixing happening in oceans, more than what's happening on the soil. Soil is not stirred by winds or convection currents, so the heat cannot be mixed up and down. So the surface temperature changes more rapidly than compared to water bodies. So thus the heating or cooling of air layers adjacent to solid ground is much faster than this above water bodies. So let's look at this figure right here. If this is our planet, we'll have here the equator. We do have low pressure, followed by high pressure, followed by low pressure, followed by high pressure. And this goes north and south of the equator. This will coincide with lots of wind patterns that goes from one direction to the other above the atmosphere and then at the lower atmosphere. So it's in one direction going up and down. So this is rising air. It goes in this direction and then it subsides again because of the high pressure, and then it goes on the other direction. This is why you will find places that are very close to each other and they have very different climatic patterns. So, for example, our region is much warmer than just the region to the north, and it's very close. This is because of different zones of pressures. And you can see that this is also switching, reversing when you go south of the equator, because the high pressure here is mirrored over here, and then you have the polar front with the low pressure. So additionally, also mountain ranges, they do play a role. So before we talk about mountain ranges, think about heater or air conditioner that you have in a room. If the air conditioner is blowing the air this way and there is a wall, it will circulate around the wall and come back. So that's how it's affecting the whole room. So mountain ranges like Himalayas or Alps are major barriers to horizontal winds. So here we have the mountains in Oman and part of them in UAE. We also have another mountain range on the Red Sea at Yemen, Saudi Arabia, and on the other side in Sudan and Egypt. So these mountains, they do play a role in how the atmosphere is moving, how the winds are blowing, and so on. Even smaller mountains and valleys can strongly influence wind directions. And you can see this in riverbeds. So for example, if you are in a city on a river, you will see that the winds or the temperature inside the river, inside if you are in a boat, is way better than if you just are on the sides. And that's because the small mountain ranges and the valley where the river is going makes it suitable for winds to blow within this valley and go. So it makes it completely different. Now let's move to the next movement, which is the vertical movement. So vertical and horizontal motions in the atmosphere interact. So they do affect each other. Driven by rising air at the equator and sinking air at the poles, you see here that there are, let's go back to this figure here. You see here that there is subsiding and rising, subsiding and rising, and so on. So these are also vertical motions. In the atmosphere, any parcel of air that is less dense than the air that surrounds it will rise by buoyancy, and any parcel denser than the surrounding air will sink by negative buoyancy. Most vertical motions in the atmosphere are caused by changes in air density. And we will use this slide again in the next video to tell you about how the air density change with temperature and humidity.